Hello, we start our first video about differential equations looking at some basic definitions and examples. A differential equation is an equation relating an unknown function and one or more of its derivatives. What we are saying is that we have an equation. What we don't know is not a variable, it's a function, and the information we have about that function is written on terms of its derivatives. So for instance, we may be trying to find the function f such that 3 times the derivative of f is equal to f times cosine of x. So the unknown here is a function f. From the notation, it follows that it should be a function of x. And we have some information about the relationship between f and its derivative, and also a cosine function is involved over there. But that's not important, it could be any other piece of information. Let me write another example of a differential equation. Let's say that we know that the derivative of y with respect to x, so here our function is y, minus the second derivative of y with respect to x 2 times is equal to y squared over 3. So again, we have an equation. The unknown, what we would like to find, is the function y, which is a function of x. And we have some information about the relationship between y, its derivative, and its second derivative. That's what we mean by a differential equation. Let me write one more. Let's try to write one that is easier so we can actually guess what the solution is. Let's say that we know that the derivative of y is equal to 2 times y. That's also a differential equation. A solution is going to be a function that satisfies the differential equation we are talking about, and that has to happen for all the values in the domain of the function. So for instance, if we look at the last case that I wrote, the differential equation is y prime is equal to 2 times y. So I think we can guess what the function is in this case. Let's say that y of x is equal to e to the power of 2x. Okay, let's see what I'm doing here. If you tell me the function and the derivative are the same, then I'm running towards the exponential function. But we also have a 2 that is coming down when we take the derivative of the e, and that's why I wrote e to the 2x over here. We could also have a constant multiplying this that wouldn't change the result. So let's verify that this is actually a solution. So that's a function y. So y prime is going to be k times 2 times e to the power of 2x. The 2 is coming from the application of the chain rule in this case. So yes, it's true that if I multiply by 2 the original function, I get the derivative. So that's for each value of k, that is a solution for the differential equation, let's call it star over here. This brings us to the next definition. What is a general solution? It's the family of all the possible solutions of the equation. So in the case I have over here, this is a general solution. I have k over here, so for different values of k, I'm getting different values of the function. And we'll see later that actually all the possible functions to the differential equation star are over there. We need this definition in contrast to the next one that says what is a particular solution. So instead of all the solutions, it could be that we are only interested in one of them. For instance, let's say that we have the additional piece of information that we know that the function we are looking for, when evaluated at the value 0, gives the result 1. That's an initial condition. So from all the functions, from all the family of the general solutions, we want to find the one that verifies that condition. So we need to find which value of k will make that true. So when we evaluate the function at 0, we are going to have k multiplying e to the power of 0. So we are going to have k multiplying e to the 0, so 1. So this has to be equal to 1. So we need the value of k to be 1. So that means if I write the differential equation and then I add the condition, the initial condition that the function at 0 takes the value 1, if I consider these two things together, then my solution is going to be that y of x has to be k is 1, so e to the 2x. And that's what we call an initial value problem. So that's exactly what I wrote over here. Let me move it over here. It's a differential equation together with an initial condition. And let me also move, since we are doing it. That's the solution we have for the initial problem. The last definition we need is what is a first order differential equation. It's a differential equation with only the first derivative of the function involved. So the first example I gave is a first order differential equation. The second is not, because we have a second derivative. And the third is also a first order differential equation. And we are going to see in the next few videos how we can solve at least some types of first order differential equations.